we begin with cubes. All right, just up to 20. 1, 8, 27, 64, 125, 216, 343, 512, 729, 1000, 1331, 1728, 2197, 2744, 3375, 4096, 4913, 5832, 6859, 8000. And in reverse, or rather with their hooks actually. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216, 7 cubed is 343, 8 cubed is 512, 9 cubed is 729, 10 cubed is 1000, 11 cubed is 1331, 12 cubed is 1728, 13 cubed is 2197, 14 cubed is 2744, 15 cubed is 3375, 16 cubed is 4096, 17 cubed is 4913, 18 cubed is 5832, 19 cubed is 6859, 20 cubed is 8000. All right. And now for the tens by their digits. 1331, 1728, 2197, 2744, 3375, 4096, 4913, 5832, 6859, 8000. Okay. And now in reverse. 8,000, 6,859, 5,832, 4,913, 4,096, 3,375, 2,744, 2,197, 1,728, 1,331, 1,729, 512, 343, 216, 164, 27, 8, 1. All right. And now, let's see now. Okay, so we need to build 21 to 25. 9,261, 9,261, 9,261. 21 cubed is 9,261. 10,648, 10,648, 10,648. 22 cubed is 10,648. So 9,261, 10,648. 12,167, 12,167, 12,167. 23 cubed is 12,167. All right, so 21, 22, 23, 3 times. 9,206. 9,261, 10,648, 12,167, right? All right. 9,261, 10,648, 12,167. 9,261, 10,648, 12,167. And one more time. 9,261, 10,648, 12,167. And now 24. 13,824. 24 cubed is 13,824. 24 cubed is 13,824. 25 cubed, I know. 15,625. 12,167. 12,167. 13,824. 12,167. 13,824. 12,167. 13,824. Okay, I think we can get 21 to 25 now. 9,261, 10,648, 12,167, 13,824, 15,625. Okay, so it's reasonably there now. And now let's begin chapter 6. Which is circles. Okay, a circle has center 2, -3 and passes through 6, 0. Find its radius and equation. Okay, so we find the distance from 2, -3 to 6, 0. All right, that distance is 5. Now, its center is 2, -3. So we're going to use x minus a all squared plus y minus b all squared equals r squared, where a comma b is the center of the circle. So x minus 2 all squared plus y plus 3 all squared equals 5 squared. Okay, you say to me the center of the circle is 2, -3 and it passes through 6, 0, and you ask me what is the circle's radius and what is its equation. And we say to you x minus 2 all squared plus y plus 3 all squared equals 5 squared. And the radius is 5. State the center and radius of this circle. X at 4 all squared plus y take 1 all squared equals 36, and hence find its lowest point. Its center is -4, 1, and its radius is 6, and hence its lowest point is -5, or -4, -5. So you say to me, to find the radius and the lowest point of this circle. X at 4 all squared plus y take 1 all squared equals 36. And we say to you the radius is 6 and the lowest point is -4, -5. A circle has center the origin and passes through 3, 4. Find its equation and tell me if -5, 0 lies on it. Its equation is x take 3 all squared. No, beg your pardon. Its equation is x squared add y squared equals 25. So indeed. Okay. The internet broke, but now it's back. A circle has center 1, 2 and passes through 5, 5. Find its radius and tell me if 2, 6 lies inside the circle or outside the circle. 1, 2 is its center, so its radius is 5. Applying the Pythagorean theorem to the 2 points 1, 2 and 5, 5, its radius is 5. But does 2, 6 lie inside or outside the circle? Well, we need to know if the distance between 1, 2 and 2, 6 is greater than or less than 5. So we apply the Pythagorean theorem on those points, right? Now, the change in y values is 4, and the change in x values is 1. So the distance between them is root 17, and that is less than 5. So 2, 6 lies inside the circle. So you say to us that a circle has center 1, 2 and passes through the point 5, 5 and ask us if 2, 6 lies inside or outside the circle. And you ask us for its radius as well. We tell you its radius is 5 and 2, 6 lies inside the circle. A circle has center -3, 4 and passes through the origin. Find its equation and the point diametrically opposite the origin. Okay. Its equation is x at 3 all squared plus y take 4 all squared equals 5 squared. And because its radius is 5, let's think now. We have to do exactly the same instructions that take us from the origin to -3, 4. So it would be negative 6, 8. So you say to us that a circle with the center negative 3, 4 passing through the origin, you want to find its equation and you want to find the point diametrically opposed to the origin. And we say to you that its equation is x add 3 all squared plus y take 4 all squared equals 25. And the point diametrically opposed to the origin is negative 6, 8. Okay, section 2 is center and radius by completing the square. Find the center and radius of x squared add y squared take 6x add 4y take 12 equals 0, and hence find the greatest y coordinate. Okay, we put the x terms together and then the y terms together and complete the square and rearrange it to the standard format of a circle. So x take 3 all squared plus y add 2 all squared, which generates an excess of 13, which we have to take away from 12, and thus the radius ends up being 5. So to be clear, the equation of the circle is x take 3 all squared plus y add 2 all squared equals 25. And if the center is if the center is 3, 2, then the greatest y coordinate is 7. So you ask us, what is the equation and greatest y coordinate of the circle x squared add y squared take 6x add 4y take 12 equals 0? And we say to you that the equation is x take 3 all squared plus y add 2 all squared equals 25, and the greatest y coordinate is 7. Find the center and radius of x squared add y squared add 2x take 10y add 17 equals 0. That can't be right. No, it is. Find the center and radius of the circle x squared add y squared add 2x take 10y add 17 equals 0, and tell me if it crosses the y-axis. So by completing the square, we find that the center of the circle is negative 1, 5, negative 1, 5, but to get the radius, well, to get the radius, you notice that you've generated 26, and so we have to take 26 from 17, and we get negative 9. But we move that to the other side and we find that the radius is 3. Now, I keep thinking that I've mixed up the signs there. No, that was correct. But I have to begin again. Find the center and radius of x squared at y squared at 2x, take 10y at 17 equals 0. And tell me if it crosses the y-axis. Let's just find the equation first. So x at 1 all squared, add y take 5 all squared. Take 26 at 17 equals 0. Move that minus 6 at 17 to the other side to get 3 squared. So the center is negative 1, 5, negative 1, 5. And the radius is 3. It crosses the y-axis, we can see it. So you asked us for the center and radius of the circle x squared at y squared at 2x, take 10y at 17 equals 0. And you asked us, does it cross the y-axis? And we say to you the center is negative 1, 5 and the radius is 3, and it does indeed cross the y-axis. Find the center and radius of the circle x squared at y squared, take 8x, add 6y equals 0, and hence confirm if the origin lies on the circle. Okay, so by completing the square, we convert the equation into the standard equation for a circle. X minus 4 all squared plus y plus 3 all squared equals 5 squared. Now, the center is negative 4, 3, and the radius is 5. And so the origin must lie on the circle. So you gave us the circle x squared at y squared, take 8x at 6y equals 0, and you asked us for its center and radius and whether or not the origin lies on the circle. And we say to you that the center is 4, negative 3, and the origin does. Oh no. No, wait. No, that is right. I think I said it right. Find the center and radius of x squared at y squared, take 4x, take 6y at 9 equals 0, and hence determine whether or not it touches the x-axis. Is that right? No, that's not right. Find the center and radius of x squared at y squared, take 4x, take 6y at 9 equals 0, and hence find out whether or not it touches the y-axis. Okay. The center is 2, 3. But that generates an excess of 13, which we must take away. And we've taken that away from 9, which gives us a radius of √3. No, it doesn't. It does not touch the x-axis. Oh, we didn't tell you that. So you gave us the circle x squared at y squared, take 6x, take 8y, add 9 equals 0. And you asked us for its center and radius and whether or not it touches the x-axis. And we tell you that the center is 2, 3, the radius is √3, and it does not touch the x-axis. Okay. Find the center and radius of x squared at y squared at 6x at 2y, take 6 equals 0, and tell me whether or not 0, 3 lies inside it or outside it. So x at 3 all squared plus y at 1 all squared, which generates an excess of 10, which we take away. So the radius is 4. So to be clear, the equation of the circle is x take 3 all squared plus, no it isn't. X add 3 all squared plus y add 1 all squared is equal to 16. Okay, so find the distance between 3, 1 and 0, 3. Well, that would be √13, right? And is that more than or less than the radius? Well, it's less than. Okay, so the point lies inside it. No, I can't remember. I have to do it again. Do it again. Find the center and radius of x squared at y squared at 6x at 2y, take 6 equals 0. Find the center and radius of x squared at... Again. Find the center and radius of x squared at y squared at 6x at 2y, take 6 equals 0, and tell me if 0, 3 lies inside it or outside it. Okay, so the equation of the circle is x at 3 all squared plus y at 1 all squared, which generates an extra 10, which we must subtract, which puts a 4 squared on the right hand side. Do you see it? I see it. So the center is -3, -1, and the radius is 4. And no, because the distance between the center and 0, 3 is 5, which is greater than the radius, so it lies outside the circle. There. Okay, great. And now, intersection of a line. It's just so excessively noisy. Intersection of a line and a circle. The line y equals x at 1 and the circle x squared at y squared equals 25 intersect at the point A and B. Find their coordinates and the length of AB. Very well. Replace y squared in the circle equation with x at 1 all squared and then solve for x. So we get 2x squared at 2x take 24 equals 0. So x squared add x take 12 equals 0. So x at 4 times x take 3 equals 0. So x is either -4 or 3, and hence y is either -3 or 4, and the distance between them is 10. So you say that y equals x at 1 and x squared at y squared equals 25 intersect at the points A and B, and you ask us to find their coordinates and the length of the line segment AB. And we tell you that the coordinates are -4, -3 and 3, 4, and the distance of the line segment AB is 10. Find both values of k for which the line y equals 2x at k is tangent to the circle x squared at y squared equals 20. Okay, so two x at k all squared. No, rather, x squared at 2x at k all squared equals 20. Now, let's think. So 4x squared at 4kx, 4x squared at 4kx. No, 5x squared, 5x squared at 4kx. Add k squared. Take 20 equals 0. There must be a simpler way of solving this.